So we spent the last week talking about applying the first derivative to optimization problems, maximizing area and volume, or minimizing a sum or a product. So now we're going to take the same concept of the first derivative and use that towards the economic application problems. So first you need to write down the four vocabulary terms we're going to be using throughout the day, today and tomorrow. So we're going to pause the video so you can copy them in your notes. These are no different than the ones we did first semester. The only added equation we have is the average cost function. Revenue is money you earn, and profit is the money you earn after you take away and subtract your cost. So we're going to apply that now to the first word problem in your packet. So looking at this word problem, the $10,000 and the $12 per unit we're going to use for all the cost equations. And the $20 that we're going to sell it for $20, we're going to use that for revenue. So starting with the cost equation, it's a fixed cost of $10,000 plus $12 per unit. Anytime you see the word per, that's your slope. So it's multiplied by the quantity. The average cost is we're going to take our cost equation and divide it by Q. And be really careful here. When you divide a sum, you're really dividing both pieces. So when we go to simplify this equation, these Q's can cancel. Now for the revenue, that's for the money we earn. We earn $20 per unit. And lastly, for the profit, that's the revenue minus the cost. And you have to be really careful when you subtract your cost equation, because we're going to have to distribute the negative. So this negative applies to both pieces. And then we can combine our like terms of the Q's. So our profit equation is 8Q minus 10,000. Now to find the values for 1,000 units, we're going to plug 1,000 into each formula. So for the average cost, I'm going to plug that into my simplified version. Now with your calculator, we're going to pause the video so you can actually calculate those two numbers. Okay, so for the cost, you should have gotten $22,000 for the 1,000 items. And for the average cost, you should get $22 per one item. In this case, the item is a mini tape deck. Now for the revenue, I'm going to plug the 1,000 into the revenue equation, and that is $20,000. And for the profit, it's 8 times 1,000 minus 10,000. In that case, we get a negative $2,000. So that means we'll actually lose money if we only sell 1,000 mini tape decks. Now lastly, to to break even, that's when our profit will equal our revenue. So there's two ways that we can find this. Either when profit equals revenue, or it is when your, I'm going to correct that. It's not when your profit equals revenue, it's when your cost equals. So the amount you spend will equal the amount you earn. The other way is if your profit formula equals 0. So I'm going to start by using the profit. So 8Q minus 10,000 equals 0. So we're going to solve for Q. So I added the 10,000 to both sides. Now I'm going to divide by 8. We get Q equals 1,250 items, or mini tape decks. So now, going a step further to our calculus, when we talk about the derivative of any of these functions, we use the word marginal. So the marginal cost function is the derivative of the cost. The marginal average cost is the derivative of the average cost function. So we're going to pause the video here so you can write down the meaning of the different symbols. So the derivative of the cost function is referred to as marginal cost, as we see above here. And it's associated with the production of Q units. So if we think about the derivative as the rate of change, because derivative means slope, and slope is the rate of change, then the marginal cost, or the derivative of the cost, is the rate at which the cost changes with respect to the number of units that are produced. So we're going to use our definition of the derivative, thinking about limits again. So the derivative of the cost, the limit as h approaches 0, of the cost function minus h, plus h, minus the cost function all over h. So as h gets really, really small and close to 0, then we say that the derivative equals this. We're just taking account if h is small, that's our limit as h approaches 0. Now, economists, when they work with marginal cost, they often let h equal 1. 1 is a lot easier to work with than a really small decimal close to 0. So therefore, the derivative of the cost, or the marginal cost, is approximately, so I'm going to change my equal signs to be approximately the cost of number of units plus 1 minus the cost of that many units. So therefore, in this context, the production of n units is approximately the cost of producing one more unit. So the marginal cost we can think of as approximately being the cost of producing just one more unit than the number of n. Okay, so an electronics company estimates the cost in dollars of electronic toys to be this formula. So we're going to find the cost, the marginal cost, and the average cost for 500, 100, and 5,000 units. So that means first we need the average cost formula. And I'm going to take each term of our cost and divide it by Q. So the average cost is 200 over Q plus 0.05 plus 0.001 Q. These Q's cancel, the squared and the 1 on the denominator cancel there. Now our marginal cost, which is the derivative, we're going to use our normal derivative techniques, exponent times the coefficient, and then that Q goes away, plus now 0.001 times 2 is 0.0002 Q. Now I want you to pause the video here, and you're going to take 500 and plug it in to the cost equation, the average cost equation, and the marginal cost equation. And then you're going to check your answers once you unpause the video. Okay, so now that I have the answers written in, pause the video again and check to make sure you have them right. For finding part B here, remember what we said on the page prior, that economists often use plus one more unit to be the same thing as the marginal cost. So whatever we find for the marginal cost of 1,000, using our derivative, we found that to be 25 cents. We could also say that is the cost of producing 1,001 units minus the cost of producing 1,000. So the cost of producing 1,001 units, we're going to use our original cost equation. When you plug that in, you're going to get $350.25. And actually, I should change my equal signs here because it's just an approximation. It's not an exact value when you find it using the n+1. Now, if I plug in 1,000, we found that that cost was $350. And when we subtract, we get the same answer of 25 cents. Okay, your task now in the packet is to do 5.4a. The first two problems have a part A and B. Part 3, or number 3, is a word problem. And then 4 and 5 are on the back. All of the answers are at the bottom. Make sure to check your work.